Don't do that.
Y3ZNQ. N as in Niagara. Q as in quintessential. All right. It smells kind of good. Oh, okay. Got 10 people. Thank you, Abina. Araceli. Yeah, the Wi-Fi I know has been spotty today, but just be patient with it.
Spotty everything.
Janelle, JT, Lance, Lisa, Melissa. Nico, are you able to join us in this near pod? If you're there, Nico. I'm going to go ahead and get started. We've got 13 folks. That's pretty good. So today is the first day of our 9th unit. This 9th unit is going to be all about ecosystems, and specifically with the focus on the human impact on our ecosystems. So we're going to talk a lot about things that I'm sure you all have heard a lot about in the news recently. There's some good documentaries that I will recommend to you all to get an idea of what the human impact has been on our ecosystem in recent decades. And then we're also going to talk about the history of how we got here. And then from there, we're going to make some future projections about where we are headed if certain outcomes come to fruition. So today we're going to focus on defining ecosystems, thinking a little bit about ecosystems before we actually jump into the human impact. The objective today is to infer how human activities may impact the environment. So on your EOC exam, which of course is coming up on this in this class on May 25th, I want to say, whatever the Wednesday of that week is. So it might be the 26th, but it's coming up last week of May. On the EOC exam, you will be given a specific scenario, and you'll be asked to kind of think through how human activities may have contributed to that scenario. So that's what we mean by infer. You won't be given specific instructions, but you'll be given an idea, and you'll have to come to a conclusion about that. I love that I see Araceli has her notebook out. Ashanti has hers. Looks like Lisa has hers. Janelle has hers. I know some of you take virtual notes, but I like people who write things down. It's a good idea. We've got 2 essential questions today. How have humans gradually impacted the environment? What are the future consequences of these impacts? So you all will really explore those as a part of your asynchronous assignment, but we'll talk a little bit about it as well. That's a little better. Today is April 22nd. It's Thursday, so I know we're ready to get to this weekend. I am. I speak for myself. Okay, so first definition, pretty simple. What is an ecosystem? An ecosystem, quite simply, is a community made up of interacting biotic and abiotic factors. They interact. We're going to explore this idea a little bit more. So what does it mean to be biotic? What does that word mean? Yeah, it's living. And then abiotic, therefore, means non-living. Thank you, Sully. Thank you, Lance. Biotic means living. Abiotic means non-living. It's cool that we see the Spanish translation of the word living there, viva. Of course, when we see that, it's got Latin roots, so you know the word Vivacious, that means somebody who's full of life. Vibrant, that means, again, really lively. All right. So this is going to be a quick 2.5-minute quiz, 10 questions. Each question is going to give you something and ask you if that thing is biotic or abiotic. You've got to just select one of those two options, biotic or abiotic, starting in 3, 2, 1. Why is it not showing up? We're about halfway through, 1 minute and 15 seconds left. I see most of you appear to be done or close to it. Yes. Thirty seconds. All right, excellent. So you can see the results. 92 correct, 8 incorrect. Not bad, not bad. Did any of them give you pause where you like, I'm not sure if that one's biotic or abiotic? Which ones? Coral, yeah. And you said grass. Okay, soil. I think soil is one that a lot of students kind of have to toss around in their mind a few times. It's important to note that soil itself is really just ground down rocks. Of course, it has a lot of other things living inside of it, but for the most part, it's just, non-living minerals. Grass, of course, is its own organism. Grass has to reproduce. It needs water to do respiration. It produces oxygen through photosynthesis. What about viruses? We talked about those last week. Viruses are non-living. They're abiotic. And then somebody said one other. I can't remember. But yeah, you guys did quite well with that. Just an interesting exercise. But we see that, ecosystems are made up of both living and non-living factors. Was that you, Paris, who needed? Who was that? Abina? Or was you, Deasia? Okay. Okay, you're good. Okay, so of course, on planet Earth, we've got a lot of different ecosystems. Ecosystems can be quite large. They can be as large as a continent. The Sahara Desert is about the size of Europe, the entire continent of Europe. But an ecosystem can be small if it's a self-contained system with its own plant life, some abiotic factors contributing as well. Like a pond, that could be considered its own ecosystem. And of course, we see abiotic factors playing a large role in ecosystems as well. Rainfall plays a huge role in the type and amount of life that you see in a given space. The temperature, humidity, quality of the soil plays a role in the amount and health of the plants that you see growing in a specific area. And then the air quality and altitude also play a role. So we see non-living factors also contribute quite heavily to the type of ecosystem. All right, this was just a question I was having some fun with, and I was just kind of doing a would you rather kind of deal. So would you rather be dropped off in the middle of the Pacific Ocean or the Sahara Desert? This is just total opinion. Let's say you're in a boat. You're in a boat, but like not even a boat, like more a life raft. You have nothing. It's just you. Most people are saying, oh, okay, most people are saying the Sahara.
If I was a better swimmer, maybe I would live a bit longer.
Oh yeah, a lot of people in my last class were just saying that they can't swim, so that kind of like disqualifies them. But if you're in a life raft, you might be okay. Yeah. That the sun exposure is going to be deadly in either situation. Yeah, that's true. That's true. It's true. You raise a lot of good points. Personally, I would be in the Sahara too. But you're going to be. Does anybody say has two people have said the Pacific Ocean? Yeah, I want to know. Why do you say the ocean? Okay. What about food though? You can't drink salt water. Yeah, Yeah, that's tough. That's tough. Has anybody seen the movie Castaway? Great movie. Or The Life of Pi. Anybody seen The Life of Pi? Do you guys watch movies? That's The Life of Pi. That's The Life of Pi. That's a great movie. You should check it out. It gives you some ideas about how you could potentially survive in the middle of the ocean. Oh no, I can't do that. Can't do that. But good idea. All right. And then on a larger scale, when we zoom out a little bit, Earth has a lot of different biomes. And these biomes are characterized by basically where they're located on the planet. So if you're closer to water, that gives you a certain set of characteristics. If you've got a higher or a lower latitude, meaning you're closer to the poles, that gives you a certain set of characteristics. And also your altitude. So if you're in a mountainous region, that gives you a certain set of characteristics. But we see that, we see shared characteristics in places that we don't typically associate with one another. For example, here in North Carolina, we're in a temperate mixed forest region, and that would be most similar to Estonia. And in some places in northern North Korea, eastern China, we also see that same biome. In the Western United States, we do have some desert environment as well as some semi-arid environment. So we can see some of that in Uruguay. We can see some of that in Argentina, in Australia, even in Yemen, which is over here. And then, of course, we see some tropical forests as well, the Amazon, but then also Western Africa is a tropical forest, as well as the Philippines and Indonesia. All right, so shared characteristics, and again, a lot of that is determined by where you are in terms of latitude. So closer to the equator obviously puts you in warmer regions where you receive a lot of sunlight all year round, and they can also be some of the more wet, humid regions as well. But then just north of the equator and just south of it, you see some desert regions as well. So it's quite interesting stuff. You guys learned about that, I'm sure, in Earth and Environmental Science. Okay, so question, and I'm going to actually make this an activity. You guys will be able to answer. What is the relationship between biotic and abiotic factors in an ecosystem? Which depends on which? Slowly, slowly. It'll come up eventually. All right, there it is. So go ahead and shoot me an answer to that question. Okay. So we've got just over half of us have participated. Oh, 71%. Good. So some of you go ahead and throw in your answer as I start to read some of the responses we've gotten so far. Someone says all the living and non-living parts of an ecosystem, period. Not exactly sure what that means, but thank you for participating. Biotic factors depend on abiotic factors. So plants, which are biotic, need sun and water to survive, which are abiotic. Great point. Excellent. That's exactly what I was looking for. Let's look at, you're welcome. Let's keep looking. Biotic factors depend on abiotic factors. True. They both depend on one another. So we've got a good example of a biotic factor depending on an abiotic factor. I'm wondering if we can think of kind of the reverse. Good, good. So Lance is saying that soil, which is obviously an abiotic factor, depends on earthworms and probably other insects as well to irrigate it or to provide other minerals and gases to it. That's very, very true. Good point. Some biotic organisms use the abiotic factors around them to survive in ways like digging holes for shelter. Yeah, shelter is a resource that we don't often talk about or think much about, but of course it is. Most organisms do need, most animal organisms do need shelter. Producer and consumer, biotic depends on abiotic and vice versa. Exactly. They both, biotic depends on abiotic. Good. Good. Water and sun. All right. Excellent. How can I close this? You want to end this activity? Yes, I do. Thank you. So this is exactly what I was going for. Biotic factors depend on the abiotic factors for survival. We can think of respiration. Of course, organisms need glucose as well as oxygen, which are both abiotic factors for respiration. What is needed for photosynthesis? Which abiotic factors do we need for photosynthesis? Sunlight. What else? Water. And there's one more. Not oxygen. Carbon dioxide. Good. We need those three abiotic factors for photosynthesis. We also need shelter. Someone pointed that out. I'm not sure who that was, but that was a great response. I hadn't even really talked about that one with my last class, so that was good. But then we also know that biotic factors influence their environments, and Lance gave us a great example. Someone in my last class also mentioned viruses. We talked about the fact that viruses are non-living, but they need a living host to not only reproduce, and I put that in air quotes because it's not real reproduction, but to be passed on. They need a living host. So that's a great example as well. Okay, you don't need to write this down, but just like we talked about the levels of organization for species, for living organisms, we can think about the levels of organization for the larger Earth. Of course, the biosphere is the terrestrial Earth. It contains all of the ecosystems, as well as the marine Earth as well. An ecosystem is multiple communities of biotic organisms interacting with abiotic factors. A community is multiple populations. So this is typically different species, both plant and animal, and in some cases, unicellular species that live together in a defined area. A population is multiple organisms from the same species that mate with one another. They provide resources to one another. They do not necessarily compete directly for resources. And then an organism, of course, is just an individual. Yes. I don't know what you're talking about. Tardigrades. Oh, the water bear. Okay. Definitely multicellular. Yeah, micro animals. They're 8-legged. Ugh. All right. Good question. Okay, so we are going to now watch a video. Araceli, can you turn off the front row of lights? I think it's the light switch on the right. Thank you so much. So in this video, as we watch it, I want you to think about how humans have impacted the planet. Just the front row. Thank you. And as you're thinking about it, not only think about how humans all over the earth have impacted the planet, but think about what you personally have done. Not just bad things, but good things as well. How have you had some type of impact on the planet? Okay.
Fun fact, planet Earth is 4.5 billion years old. Mankind, about 140,000 years old. Let me put that in perspective. If you condense the Earth's lifespan into 24 hours, that's one full day, then we have been here on this planet for, drum roll please, 3 seconds. 3 seconds. And look what we've done. We have modestly named ourselves Homo sapiens, meaning wise man. But is man really so wise? Smart, yes, and it's good to be smart, but not too smart for your own good. Yes, we have split the atom. Yes, we build clever machines that navigate the universe in search of new homes, but at the same time, those atoms we split created nuclear warfare. In our quest to explore the galaxy, rejects and neglects the home that we have here now, so no, that cannot be wisdom. Wisdom is different. While intelligence speaks, wisdom listens, and we willingly covered our ears to Mother Nature's screams and closed our eyes to all of her help-wanted signs. Wisdom knows that every action has an equal and opposite reaction, so if we were wise, we would not be shocked when we see storms that are stronger than ever before, or more drought, hurricanes, and wildfire than ever before, because there's more pollution than ever before, more carbon, more trees cut down than ever before at a record pace. We have extinction of animals by 1,000 times the normal rate. What a feat. In the next 10 to 100 years, every beloved animal character in every children's book is predicted to go extinct. Lions gone, rhinos gone, tiger, gorilla, elephant, polar bear gone. In 3 seconds. Species that have been here longer than us will be gone because of us. In this 3 seconds. In an existence shorter than a Vine video, we turn the circle of life into our own personal conveyor belt. Somebody, anybody help. We were given so much, the only planet in this solar system with life. I mean, we are 1 in a million. No, actually, scientifically, we are 1 in a billion, trillion. That's a 1 followed by 33 zeros. And I don't want to get too spiritual, but how are we not a miracle? We are perfectly positioned to the sun so we don't burn, but not too distant so we don't turn to ice. Goldilocks said it best. We are just right. This paradise where we are given medicine from trees, not coincidentally, but because like the song says, we are family. Literally, everything, every species is connected genetically from the sunflower to the sunfish. And this is what we must recognize before it's too late, because the real crisis is not global warming, environmental destruction, or animal agriculture. It is us. These problems are symptoms of us, byproducts of us. Our inner reflection, loss of connection has created this misdirection. We have forgotten that everything contributes to the perfection of Mother Nature. Corporations keep us unaware and disconnected, but they have underestimated our strength. Contrary to popular belief, millions are waking up out of their sleep, seeing our home being taken right up under our feet. We cannot allow our history to be written by the wicked, greedy, and loony. It is our duty to protect Mother Nature from those who refuse to see her beauty. Call me crazy, but I believe we should have the right to eat food that's safe, with ingredients we can bounce, drink water that is clean, marvel at trees, breathe air free of toxins. These are natural rights, not things that can be bargained for in Congress. See, they want you to feel powerless, but it has been said that something as small as the flutter of a butterfly's wing can cause a typhoon halfway around the world. But when enough people come together, we too will make waves and wash the world into a new era filled with love and connection, freedom for all without oppression. But it is up to you, yes, you watching this behind this screen, to make the effort, because time is of the essence, and only together can we make it to the 4th second.
All right, so again, I wanted you to reflect while watching that video, but now I want you to actually send me some responses. In what ways have humans harmed our planet? And in what ways have you contributed to some harm? Now, it does focus on the word on your personal harm, but I want you guys to think about just any impact you may have had, good or bad. Do you do things like recycle? Do you have your own garden? Do you eat food that's grown locally? What do you do to contribute, good or bad, to the planet? Littering and not littering. So sometimes you do it, sometimes you don't. Yeah, deforestation has been obviously a pretty big problem. Using gas instead of electric vehicles, I assume that's what that means. Yeah. I think probably by the time you guys are purchasing your first new cars, they will be electric. I know some of you probably already have cars or are making plans to buy some, but your first brand new car will probably be an electric vehicle. We've killed animals. Yeah, that's true. What'd you say? Yeah, yeah. Invasive animals. One good thing that many of us do is recycle. I see that's come up a couple of times. You don't recycle? It's an easy thing to do, but as we will see, one person recycling, it's not going to make a huge difference. We'll talk more about that. Monocrop agriculture. So I'm not sure who said that, but that's an excellent response. Yeah. So continually growing the exact same crop in the same place is really bad for the soil. Toxic waste. That's true. That is true. And it enters our water sources far too often. Anything else we want to add here? Looks like most of you are done typing. Okay. Pesticides and yeah, we kind of talked about this biological arms race that's taking place. We use too many pesticides. It kills off most of the insects, but then the insects that are still around are basically immune to our pesticides. So we have to create stronger ones, which is really not good for human consumption. So that can be a big problem. Large factories that we see, good points. All right. So when we look at this picture, we obviously see interstate highways. This is a pretty dense, complex interstate highway system. What impact do you think the development or construction of this system has had on its environment? Yeah. Good. So for those at home who can't hear Lance, and maybe even in the back of the room, Lance is saying that habitat destruction took place. Right, we had to tear down, chop down trees, dig into the earth potentially. He also mentioned concrete, and concrete and some of the resources that are needed to lay down concrete can be quite toxic to the environment. Concrete is basically, so it actually comes basically, it looks like sand when you buy it. If you've ever seen a bag of concrete, it looks like sand, and then you mix it with water and it hardens. But yeah, essentially. Some concrete will have some additives to make it more smooth, or to what you don't want to have happen is when you are laying concrete, you don't want oxygen to be in the concrete because the oxygen will bubble up and it can lead to the concrete cracking or splitting. Yeah, so some of them do have some chemical additives to give them special qualities. For example, a lot of highway systems now will have some additives that keep them darker, and darker reflects more sunlight, which is also a bad thing. And if you may have heard this before, but urban areas that have a lot of concrete, yes, sir, yes, urban areas that have a lot of concrete are often hotter than the surrounding rural areas because concrete is reflecting more heat, whereas trees and grass will absorb the heat. Right. Yeah. Okay, what about in this picture? Not good, Paris. But thank you for being honest with us, but please don't do that again. This is real, right? So there's a garbage patch that is in the Pacific Ocean that is about the size of the state of Texas. And that's really hard for us to picture, but it is real. And a lot of this garbage, like I said, is not necessarily coming from human, people actually dropping plastic in the ocean. A lot of it is left from the fishing industry. But there's a great documentary on Netflix called Seaspiracy. If you get a chance to watch it, I would definitely check it out. One statistic that stuck with me from that documentary is that on average, we dump about one garbage truck full of plastic into the ocean every single second. And that plastic, some of that plastic has been there obviously for decades now, and it is being beaten down by the sun constantly. It's eroding in the water, and so it's breaking down. It's becoming what we know as microplastics. We'll talk more about this. The microplastics are then eaten or just absorbed by marine life, marine animals. And eventually it makes its way back up the food chain and we eat it. So we can actually find traces of plastic in humans who eat fish today. So it's a big, big problem. When the plastic gets broken down to microplastics, there's not really much we can do about it. You can't easily pick it up. It's hard to extract when it's so small. So it's going to continue to present a large problem. Mm-hmm.
And vultures eating them because they're shiny objects.
All kinds of human impact. All right, what about this? How has this human, or what human activities have led to floods in Southeast Asia? So yeah, poor city planning is a big problem. Believe it or not, when you covered, Houston experienced this a few years ago when they had Hurricane, not Katrina, that was 2005. This was like literally like 2018, 2019. Hurricane, what was it? Yeah, Harvey, Hurricane Harvey. And Houston basically was a city that came up very quickly, and so they laid down a lot of concrete, and it kind of slopes inward. So it's basically a giant bowl. And so that's one of the reasons why the city flooded quite quickly and quite easily, because there were not enough natural landscapes to kind of absorb the water, and everything was sloping inward. So that's poor city planning that made the flooding a huge problem in Houston. But we see it in other countries as well. What else might have contributed to this? Why is the water level rising in the first place? Yeah, we there was a deadly tsunami in 2003, one of the most deadly natural events in recorded human history. It killed well over 400,000 people. And a tsunami is caused by an underwater earthquake, essentially. But in this case, we see gradual water level rising because of global warming, and it's melting the ice caps, right?
Oh, speaking of that, I watched a clip of a news reporter commenting on global warming and how people say, there's ice in my cup, why is that not raising the water level? And he said, because the ice is already there. But then he got bold and threw that at the cup and said, look, now it's outside.
Yeah.
I thought it was funny, but
Oh, what is all that?
What'd you say?
All that.
During landfills. But we have to, a lot of waste is going into landfills. That's most of it. And even then, we're running out of space for that. Okay, so you can see many of our coastal cities. Even if I drop this down, you look at the current level. Look at New Orleans. Okay. All right, so the city of New Orleans. Now, there are some cities, I'll show you, but let's just see what happens as the water level rises. So I think the blue is where it currently is. And you can see even with a foot of sea level rise, we start to see the city being encroached upon. All right, let's look at my. You can see some parts of South Beach and Miami are, even with 3 feet of sea level rise, some parts of South Beach are already underwater. But yeah, you can see coastal eastern North Carolina is at jeopardy as well with this sea level rise. So we're probably not going to get to 10 feet, but 3 feet is definitely possible, especially if we don't make the necessary changes in the next 9 years. 2030 has long been kind of that year that we need to have accomplished some major goals, if we ever want to see, or if we ever want to avoid some of the permanent damage that can come from global warming. We'll talk more about that. Okay. And then what about hurricanes? How has human activity contributed to hurricanes? Any ideas about that? Exactly. Yeah, so hurricanes are typically a result of warm air systems interacting kind of violently with cold air systems. And so that creates a pressure difference, which can lead to a hurricane. And so the hurricanes we're seeing, of course, hurricanes existed long before humans were on the planet, and they will likely continue happening long after we may be gone. But we are contributing to them being more frequent and to them being stronger because of global warming. All right. So in this class, we really focus on 7 types of human impact. Population growth. You guys have some interesting slides to look through here. Pollution, climate change, the burning of fossil fuels, invasive species, ozone depletion, bioaccumulation. So that's what you guys are going to look through for the asynchronous assignment. We've got 20 minutes. Those exact slides are provided to you. Your assignment is essentially to define those 7 phenomena and to talk about the human impact. I want you to use your own words. So please do not copy and paste from the slides. Please do not copy and paste from a website. Come up with your own sentences. And that will, of course, be a part of your grade. All right. So this very first asynchronous assignment is available to you now on Canvas. It's U9D1, Human Impact on the Environment. We've got 20 minutes. That's plenty of time. Yes, ma'am. Yes. you all. Have a great rest of your day, and I'll talk to you tomorrow. Thank you, Melissa. See you, Sully. Thank you. Happy birthday, Ashanti.